Chapter 5, Section 7 is about the Pythagorean theorem. By the end of this lesson, you should be able to use the Pythagorean theorem and its converse to solve problems, and you should also be able to use Pythagorean inequalities to classify triangles. Right now, I want you guys to do this slide and this slide on your own. So pause the video, try both of those, and see what you get. Now hopefully you figured out that if you add the 9 and 16, you end up with 25. If we go back here, if we take this square here, these 9, so right here, and add 16 more, so these guys here, you got 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, you end up with 25. And this proves the Pythagorean theorem, which says if you take whatever this length is, this would have a length of 3, this would have a length of 4, and you square both of those, like literally make a square, and then find the areas, you end up with the square of C here. And that's where a squared plus b squared equals c squared comes from. Here's another proof. This one's a little more algebraic than the last one, so more people tend to like this one if you like algebra rather than just counting. So let's say we have this triangle. It has to be a right triangle, and it has two sides, A and B, and a hypotenuse of C. So if we turn this triangle and make it into a giant square, and we have this other square inside of here, the light colored one, we know that the area of the whole square is whatever the length is, so A plus B all squared. Now if we FOIL this out, this is A plus B times A plus B, which gives us A squared plus AB plus BA, or we could write AB plus B squared. This can be simplified to A squared plus 2AB plus B squared. So that's the area of that whole big thing, this whole big thing in here. Or we know that it's the 4 triangles plus this square inside of here. Now the 4 triangles have an area of 1/2 their base, which is B, times their height, which is A. And then this square inside of here is C times C, or C squared. So if we simplify this, this is 2AB plus C squared. Now both of these have to equal each other because it's literally the same square. I just found the area 2 different ways. So I can set A squared plus 2AB plus B squared equal to 2AB plus C squared. And then you can see here, because you have the 2AB on both sides, if we subtract it out, it goes away, and we're left with the Pythagorean theorem. So 2 ways to prove A squared plus B squared equals C squared. So let's use it. You need to be able to figure out what side you're solving for. Sometimes you're going to solve for a leg, sometimes you're going to solve for a hypotenuse. That paper on the back of your notes, you're going to write yourself an example of what you're solving for when. So your hypotenuse, remember, is always across from your right angle. So in this case, we're looking for C. So if we have A squared plus B squared equaling C squared, it doesn't matter which one we call A and which one we call B. They're both legs. So let's plug in 6 squared plus 2 squared has to be C squared. We get 36 plus 4, we get 40. And then to solve for this, we need to take the square root of both sides. So we end up with C equaling the square root of 40. Now remember, you have to write this in simplest radical form, which means break this apart. Find a perfect square that goes into 40. And 4 sticks in my mind. So this is really like the square root of 4 times the square root of 10. So since the square root of 4 is just 2, this becomes 2 root 10. And that's how long that side is. Remember, even though that doesn't look like a number to us, that's still a number. 2 times the square root of 10. It's just an exact answer versus a rounded answer. Just like fractions, like 1/3. If you write 0.333, this is rounded where this one's exact. Same thing if we were to type the square root stuff into our calculator. This is an exact answer. So now this one's a little harder. Most things are in terms of x, but we can still use the Pythagorean theorem. So let's make this one A and this one B. Again, remember it doesn't matter, but that one has to be C because it's your hypotenuse. And then plug stuff in. X minus 2 squared plus 4 squared equals x squared. So remember, you have to FOIL this. Do not get x squared minus 4. You have to do x minus 2 times x minus 2. Now this gives us x squared minus 4x plus 4. 4 squared gives me 16, and that equals x squared. So if we go to simplify this stuff, if I subtract this x squared from both sides, it goes away, which is awesome because this is much easier to solve. I'm going to add 4x to both sides. So if we come back up here, I get that 20 equals 4x. And if I divide by 4, that gives me 5. So I found the value of x. Give my answer in simplest radical form. Since this one was a nice pretty answer, that is simplest radical form. Randy's building a rectangular picture frame. He wants the ratio of length to width to be 3:1 and the diagonal to be 12 centimeters. How wide should the frame be? Round your answer to the nearest tenth of a centimeter. So let's draw ourselves a picture. We have this rectangular picture frame, and we want the ratio to be 3:1. That means whatever this side is, this side has to be 3 times bigger. So if we don't know something, make it x. So this has to be 3x. And then he wants the diagonal, so what goes from corner to corner, to be 12 centimeters. And what we just did was made a triangle. 12, 3x, and x. How wide should the frame be? Well, we can find x with this information. So again, let's use the Pythagorean theorem. Remember, it doesn't matter what leg we stick in for A and what leg we stick in for B. This is going to equal 12 squared. So we get x squared plus 9 squared equals 12 squared, which is 144. 10 squared equals 144. And then we have to divide by 10. Remember, you need to get the x squared alone before you can take the square root. So we get 14.4. Now, let's take the square root. Now, if you notice for this one, it asks us to round our answer to the nearest tenth of a centimeter. So they knew that we were going to get a messy decimal like this. If you type in the square root of 14.4 into your calculator, we get 3.8 when we round it. So that is the width of the frame. That's what x equals. Now, if they asked us for the length, we would have to plug it in here. But since they don't, we're done. So a set of 3 non-zero whole numbers that satisfy a squared plus b squared equals c squared is a Pythagorean triple. Now the one that we did at the very beginning, 3, 4, and 5, that's a Pythagorean triple because 9 plus 16 will always give you 25. Another common one that you should commit to memory is 5, 12, and 13. And that's because 25 plus 144 will give you 169. There's several other ones. These ones are a little less important. 8, 15, and 17, and then also 7, 24, and 25 are all good ones. But these two right here are very common. There's another one, 6, 8, and 10. Because 36 plus 64 will always give you 100. So find the missing length. Tell if the sides form a Pythagorean triple. So because we're going to use the Pythagorean theorem, they will form a Pythagorean triple. So let's plug it in. Since we don't know what that is, and it's the hypotenuse, we're going to make that C. 14 squared is 196. 48 times 48 is 2,304. And when you add them together, we end up with 2,500, and that's C squared. So when we go to take the square root of this, we end up with a nice pretty 50. So because we use the Pythagorean theorem, and these are all whole numbers, because remember they had to be whole numbers, that means that these are a Pythagorean triple. So all whole numbers. So the converse of the Pythagorean theorem is just as important. So remember, the Pythagorean theorem says if you have a right triangle, then a squared plus b squared equals c squared. The converse says that if a squared plus b squared equals c squared, then you have a right triangle. So it goes backwards. So your hypotenuse states that this is true. Your conclusion then tells you that you have a right triangle. So classifying triangles. Now, you can have other triangles besides a right triangle. You can have an obtuse triangle or an acute triangle. And one way to figure this out is by using something called the Pythagorean inequalities theorem. In this theorem, it says that if c squared is a number greater than a squared plus b squared, then you have an obtuse triangle. So if this is bigger than these two added together, that means this angle has to be large. The other way around, if c squared is smaller than these added together here, that means you have a nice tiny little angle there, and it's an acute triangle. So here's an example. Tell if the measures can be the side lengths of a triangle, and then if so, classify it as acute, obtuse, or right. So the first thing we got to double check is if we add up two of the side lengths, is it greater than the third? So 5 plus 7, is that greater than 10? Yes. How about 7 plus 10? Is that greater than 5? Yes, it is. And then the last combination, 5 plus 10, is that greater than 7? And in fact, it is. So that means this can be a triangle. Now what we have to do is figure out if it's acute, obtuse, or right. So remember, the biggest one is always your hypotenuse. So we're trying to find the relationship between 5 squared, 7 squared, and 10 squared. If they're exactly equal, it's a right triangle. If c squared is greater, then it's obtuse, and if c squared is less, then it's acute. So 5 squared is 25, 7 squared is 49, and 10 squared is 100. If you add 25 and 49, you get 74. Now, since 74 is less than 100, that means c squared is greater. And because of that, you have an obtuse triangle here. So now for the next one. So first we got to figure out if it can be a triangle again. So is 5 plus 8 greater than 17? 5 plus 8 is only 13, so this is not true. It does not matter that 8 plus 17 is greater than 5, and 17 plus 5 is greater than 8. If one of them doesn't work, remember, it cannot be a triangle. So our answer here, these cannot form a triangle. So we're done. So you should be able to use the Pythagorean theorem and its converse, and then use Pythagorean inequalities to tell me if something's obtuse, right, or acute. Make sure you write down any questions you have, and we can go over them in class tomorrow. Have a good night.